Thank you for joining this webinar, which is hosted by the Collective for the Advancement of Connected Building in collaboration with Protect Collective. And our focus is on accelerated Canada transition to net zero with special emphasis on electrification of buildings. This webinar is being recorded, and if you have any questions, please put them into the checkbox. Is this topic important? That is because the demand for the electricity is increasing dramatically due to the urgent need to decarbonize and electrify the Canada's economy. And this may strain the grid, especially during the extreme weather conditions. We also know that the buildings are some of the biggest users of energy, both directly and indirectly. And while we have energy efficiency, which will reduce the consumption, we still need other means to deal with the grid, particularly with the demand. And the grid interactive efficient building might be one of these solutions. So what are the grid interactive efficient buildings? They are, first of all, energy efficient, and they use smart technologies and sometimes online distributed energy resources. Their advantage is that they provide demand flexibility, and they also optimize energy cost. So the key point about the grid interactive efficient building is that they can adjust energy usage in response to grid condition, and this way they can contribute to more resilient and sustainable energy ecosystem. We have a great lineup of panelists to explore this subject, and it gives me a pleasure to introduce the panelists. So first of all, we have Adam Mustafa from BJIS. Adam is a professional engineer, and he's also energy manager who oversees a large client's commercial portfolios. Next, we have Greg Robart, who is a Chief Executive Officer at Smart Innovation Network. And Greg brings lots of experience in building automation, electrical design, demand response, and all the aspects of energy management. Joining us also is Nadia Ahad, who's the research officer at the National Research Council of Canada. And Nadia is focused on grid generation and storage research, as well as investigating building performance, measurement, and verification. And finally, we have Sarah Simon, who is the Director of Utilities and Innovation at Power Advisory. And Sarah's expertise is working with utilities such as distributed generators, also industrial customers, as well as emerging technology providers. So I would like to thank all the panelists for joining us today. And because we have a lot of material to cover, let's dive right into it. So Adam, can I ask you, what do you see as a lay of the land? Are the buildings owners and managers concerned about increasing stress on the grid?
Thanks, Jerry, first of all, for the introduction. I definitely would agree that there is this concern. So, this has been something that's been in discussions for quite some time now, with the natural organic increase of demand throughout Ontario. Electrification has just ramped that up, as well as when you combine it with decarbonization, everyone's trying to move away from natural gas onto more electricity. And I just feel that the rate that has been accelerating doesn't match the investment that we have going into the infrastructure. There's talks about refurbishments as well for Pickering nuclear power station. So when that happens, you're going to have less available supply on the grid, which could even lead to potential brownouts in the worst case scenario. I remember during COVID, actually, there was a lot of there was basically we were informed, any Class A customers were informed that you shouldn't be curtailing during this period, but at the same time we then received emergency dispatches through the demand response program stating that, you know, if you don't go off the grid at this point, it could be you know, catastrophic for the grid. So there was this emergency event that we typically don't see in Ontario just by customers remaining online. So this is definitely a concern in the commercial world.
Great, thank you. So if it is a concern, we definitely need something to do about the smart grid. And Greg, could you tell us what are the smart grid perspective in Canada and how well are the utilities prepared? You mute, Greg.
Yeah, it wouldn't be the first time or the last. Hi, Jerry, and thanks for organizing this. Yeah, so I'm going to propose that the utilities are working to get prepared. There's market reform that is required. I mean, we don't have a capacity market to speak of in Canada. And, you know, demand response topics fit inside a capacity market. We have energy markets, kilowatt hours, but we don't buy and sell kilowatts typically. And that's where your demand comes into play. I don't believe we have any ancillary services markets, which is the fast acting stuff, which is really where the green interactive buildings come into play. And one thing I just want to share is, like, building owners have been doing demand response for 30 plus years. Like, this is not a new topic about managing demand to keep their costs low in an environment where most commercial and industrial buildings have some sort of peak charge from a capacity perspective. But what's new is the utilities are recognizing that the individual buildings are assets that they can leverage to improve the performance of the grid in real time from a capacity perspective and a frequency and a voltage response. And this is where the real opportunity for grid interoperable systems, you know, interoperable buildings come into play. There's lots of pilots going on. There are no, that I'm aware of, in Ontario or all of Canada, scaled solutions that would feel like we've got this in control at scale. And part of it is market reform, part of it is technology adoption, part of it is money. So there's a long list of reasons why, but the opportunity absolutely is there.
Excellent. Well, on that note, perhaps, Hadia, could you tell us what might be some of the opportunity in the residential buildings with respect to the grid integration?
Yeah, of course. So good afternoon, everyone, and thanks, Jerry, for moderating this and for all the panelists. So yes, I'll just jump into some of the insights from field studies that conducted by our team on some residential cases. So specifically, we conducted studies on pilot smart residential communities in Atlantic Canada, and we tested various of these demand response technologies and mechanisms to assess their effectiveness in reducing peak demand. And organically, the byproduct would be reducing operational carbon emissions, energy consumption, and customer bills as well. So for instance, we have found that most promising example was installation of solar PVs and batteries, PV and battery, for load shifting. And that has proven effectiveness of peak shaving if the battery was programmed for control or time-based control. This can also apply to any other storage mechanisms like EVs that can charge during off-peak hours and feedback. So that can not only reduce peak, but also provide energy arbitrage as well. Another example could be the use of time of use or time of day electricity rate structures that can shed demand during peak durations of the day. But that requires user engagement and users to change their behavior, so they can make use of the off-peak hours and reduce their usage during on-peak. There are a few other examples, such as combining both storage mechanisms with time of day rate structure, scheduling for dispatch events. And by dispatch here, I mean that it's a utility issued signal to intentionally affect the load changes at the end user level. So an example here could be using DER to dispatch or to discharge the battery during the peak events to provide some relief for the relief to the grid stress levels.
Great, excellent. Well, there certainly are some opportunities, so that's good. Adam, could you sort of address some of the opportunities in the commercial buildings?
Sure. Yeah, I mean, it's a little bit tricky, the fully loaded question, because one of the things are a lot of our clients as well have a lot of critical space, right? So the strategy would kind of vary building to building, depending on if you're working with white space or if you're working on, the largest data centers across Canada, right? So a lot of the times our clients are already looking at how do they fully optimize their space when it comes to heating and cooling. So if they are already at the bare bones of electricity consumption and we give the okay for a grid integration, it kind of gets a little bit scary in the sense that, okay, let's say in the middle of a heat wave, they want to signal to the building to kind of go reduce their cooling. That may kind of put a stress on our batteries, right? And if there's any situation where the building is compromised, I believe that clients are going to want to kind of take themselves out of that sort of circulation where they have to defend their own resiliency within the buildings. So there are definitely opportunities, but we have to be very cautious. I would also there are machine learning opportunities where buildings are already looking at how do they reduce the cooling the cooling within their data centers, for example, where you have solutions like Vigilant that are using a machine learning solution, which is kind of monitoring what's the requirement of the IT load versus the cooling requirements, and how do they reduce it to the bare minimal. Now, when it comes to dealing with, again, signals from the grid is to say, hey, we need you to kind of reduce your loads. It may be a little bit easier to work on the residential side versus commercial in that instance. However, there could also be non-critical loads that could easily be reduced, such as lighting. That could help remove some of the strain. We've seen curtailment in the past. That ICI program that rolled out since 2010 addressed a lot of that. However, we're trying to get to a more cleaner solution using perhaps batteries as opposed to generators. And now we're starting to see the technology that can match that sort of load on the battery side and the duration that is required with some of these programs. So there's metal air batteries, for example, which could take an incredible amount of load and for over 24 hours as well. But the footprint that is required is quite large. So you'll need a huge amount of footprint outside of the building, for example, to actually have these batteries on site. So that's part of the still part of the obstacles that we're facing today.
Excellent. When you talk about the large footprint of those batteries, would there be any opportunity to do it on a say like a community scale or like a community of building or grouping of building?
Oh, of course, and that's what we're seeing on the residential side. Like I mentioned, it's a lot more common there. When it comes to let's say downtown Toronto, it's going to be difficult to find that sort of space to do it. But in a residential site, I believe in Pickering we've seen it, in Barrie we've seen it, where they kind of group these residents together and all go on on those batteries as a way to alternative power.
Right. Now you mentioned quite a few technologies. Which one do you think would be the most realistic for the building operators to do right now?
Again, it kind of depends building by building, right? So, for example, BJS manage some of the largest telecom companies, which have media sites, for example. For those sites, if the grid is going to do an instantaneous change to the power load to the building, it may disrupt the media quality, right? If they're on a live broadcast or something like that, as well as when you're talking about financial institutions, how much capital is running through their networks. If you have an instantaneous spike that may jeopardize a system going down, even for a brief period, would be catastrophic for the business. But there are ways that we can kind of connect to the BAS to look at those non-critical loads, like I mentioned, looking at lighting. If you do it as well, have AI within the building, but it's all has to be part of the process where AI has to kind of learn what's going on within the system and how it can feed into the operators. The operators ultimately need to make decisions. However, you can't just look at it as, AI is going to dictate the operations of your building on its own. So there are definitely, I would say, opportunities for collaboration with the smart technology, with smarter controls within your buildings, lighting controls, feeding through the BAS, etc. But it has to kind of feed back, and ultimately the operator needs to be the one to press the button.
Great. Sarah, I wonder if you could tell us what would be some of the legislative requirements to facilitate the implementation of the smart grid and grid integrated building strategies.
Thank you so much. And thank you for having me today with this great group of panelists. So I'm at Power Advisory, and I'm Director of Utilities and Innovation, and I work really closely with utilities across Canada as they're navigating the energy transition. And just before I answer your question, I wanted to just provide a little bit of context before I sort of gave some recommendations in terms of the legislative and regulatory construct. So, we've heard from the panelists today about how grid interactive and efficient buildings have multiple benefits, such as energy efficiency and cost savings and reducing carbon emissions. We've also heard that for utilities, they are also offer flexibility and dispatchability and new resources there. I recently worked on a report with the Electricity Distributors Association, and we wanted to put into context the magnitude of spending on the distribution sector to achieve net zero targets. And part of the impetus of that was we recognized that many of the studies that have recently come out talking about the cost of the energy transition or what it's going to take to go to a net zero grid often overlook the distribution sector with respect to costs. So we evaluated the current gross capital additions to the distribution system in Ontario against the projected growth, both under sort of a business as usual economic development scenario, as well as a net zero scenario. And under a net zero scenario, we found that spending could increase by more than 130% by 2050. And even under a reference scenario, spending could grow by 45% by 2045. And what that means is that, while we have a baseline of $3 billion per year being spent in the distribution system in Ontario, that can grow to between $4.5 and $6 billion per year just in Ontario. So if we project that across all the, all the rest of the population, all this electrification and growth is having significant, creating significant investment requirements. And what we talked about there, and what I talk about often with my clients, is that distribution system operators and LDCs need new tools to manage this growth and to be efficient and to use resources at the customer side, such as grid efficient and interactive buildings, use those as an opportunity. So rather than building out the distribution system to meet a maximum capacity requirement, can the distribution system operator coordinate with building owners and aggregators to curtail electricity consumption during periods of high strain on the system, or to integrate renewables? Can we meet our future housing growth needs as well by maximizing the use of the existing grid infrastructure rather than over building the system for sort of rare peak events. We've seen some movement here. So in Ontario, for example, there's new non-wire solution guidelines that have been established by the Ontario Energy Board, requiring distributors to evaluate potential non-wire solutions whenever the capital expenditure exceeds $2 million. So there's good progress. I think some examples that we can see going forward. But enabling the Envision really requires that electricity distributors are permitted to invest in grid modernization tools such as ADMS, DERMS, and distribution system automation. These tools are needed by the distributor so that it has visibility of the current grid conditions and the ability to communicate and coordinate with the resources and customers to ensure stability and reliability of the grid during these peak conditions. But as regulated utilities, all of their spending is regulated by the applicable regulatory bodies such as the Ontario Energy Board and the Alberta Utilities Commission, as an example. And these regulators have legislative authority to approve distribution system rates and spending of the utilities based on investment plans and in consideration of legislative objectives. And while many regulators have some mandate within their objects to consider innovation, in my view, there needs to be a strengthening of this direction and mandate to these regulators to really enable grid modernization and establish that that's essential for the energy transition. So overall, just to your question, the legislative and regulatory framework governing electricity distributors really needs to be geared towards innovation. This includes the ability for distributors to put forward grid modernization plans that include modern technologies that allow them to efficiently operate a more dynamic grid. And I believe that distributors should have the ability to set out their own grid modernization plan that identifies the technologies that they believe are foundational and essential to their new operations. And then aside from that, there are other tools that the government could consider to enable innovation, such as things like tax credits and subsidies and research grants to develop smart grid infrastructure. But all that being said, I think there's a lot of really great work going on in Canada. I think we could push to do more. And I think the crux of it really is enabling the utilities to invest in and build out their grid modernization plans, which is essentially building to the new normal of the grid that will have much more complexity than it did 10 years ago.
Wow, great. Thank you very much. That was a great answer. Since the power is such a big element of resiliency, and we hear so much about what's going on in states, particularly with respect to the grid integrated buildings, what would be actually the implication if Canada would not advance the grid modernization? Anybody wants to pipe onto that one?
I'm gonna try one. So if we're going to if we're headed towards net zero, all reports would say we need 2 to 3 times more electricity. The electrical loads, almost all of them go through buildings. Besides your street lights and the odd infrastructure, almost all of that electricity, 2 to 3 times, goes through buildings. And my analogy is, I bet you there's nobody on this car.
Greg, we just lost you.
Oh, sorry. Sorry about that. My analogy is, I bet you there's nobody on this call that still has an automobile with a carburetor in it and doesn't have a computer, or in some cases 7 computers that actually make the vehicle work. And I mean, we still have utilities in Canada that have poles and wires and minimal digitalization. And what we're talking about is we electrify more and more of these buildings and put more renewables on. The requirement to manage that grid in real time, full visibility, it's a must-have in the future. Unlike what it was 50 years ago, we didn't need it 50 years ago because we had a way simpler system. The system's getting more complicated. This is no longer an option, in my opinion. We have to get more digital. We have to provide more visibility to the system operators. We have to have more control into the buildings, into the loads, or we're just going to break the grid and our reliability numbers are going to start to fall.
We actually have a question from Neil Larson. If anybody's aware of work related to the potential of building clusters of various occupancies and configuration to take advantage of balancing surpluses and deficit. This is something, for example, Rotterdam had this plan where they were connecting the buildings which were, having a kind of a surplus of energy with other buildings. So, for example, you could you could feed the buildings, the industrial building during the daytime hours, but that energy would then kind of go into the residential building. So you would balance the load between the different type of buildings, different type of occupancy. Anybody aware of such a work in North America?
We've been exploring not from an electricity perspective, but more so waste heat. So how we can deliver waste heat from adjacent buildings, one building to another, instead of taking the natural gas boiler approach when it's required. So that's something that I've seen be very successful in Europe, actually, and I think a lot of larger customers are looking to see how they can leverage that, especially when you're talking the amount of heat that's generated from data centers.
Great. Well, they'll be wonderful.
Yeah, just
try something like that in Canada.
To add to that, so New York Rev a number of years ago went all in on the ability for customers to buy and sell with their neighbors. And I would say that's probably one of the largest that I'm aware of, where what we're talking about sharing amongst clusters is enabled on the electricity grid specifically. Right.
Actually, we have a comment from David Katz that we need to have regulators allowed waste from the data center, for example, to adjoining residential properties. Would that be feasible?
I think we need to get creative, right?
Yeah,
so
exactly.
I mean, data centers, but other types of district heating. I'm aware of even like new thermal storage, projects that are being considered, and the flexibility that thermal storage can provide as well, and replacing some of the boilers and things like that for some regional applications. But to your point, David, there's probably a lot of inefficiencies out there with waste heat that really I think we need to be more creative about capturing.
We actually have a disagreement that we need 3 times the electricity. The point is that we probably need more electricity storage in each building and car parked, whether it's residential or commercial building. Sorry, I'm just trying to read this. Not including industrial. If the demand were fully flattened, then max 1.5 extra grid supply would be required. Do you think we could actually reduce the demand on the electricity we need by effectively using the buildings and the car as storage batteries?
It's definitely part of the equation. I think one thing you have to consider is where this 3 times the storage comes from. Actually, I read a study not too long ago where they were saying, I think in 2020, there was just under 5 million residential customers, let's call it, if each one of those owned 1.5 electric vehicles, let's say by 2050 or so, that alone would cause the peak demand to increase by 3 times the amount that we're currently seeing. So I believe right now it's about 25. That could take the peak demand up to around 80. However, there's a lot of assumptions in that, where you're assuming everyone is charging the car at the exact same time, right? So that's why these programs are introduced, like the ultra low time of use program, to incentivize people to use the electricity on the off-peak hours from 11 p.m. at night to 7 in the morning. So you're hoping that not everyone's going to be charging during those peaks. So I agree with the comment that it may not be exactly 3 times. However, it's just a ballpark estimate there, and it could be as low as 1.5. But the point is, we currently don't have the infrastructure or the capacity in place to support that. So thermal storage is definitely going to be a part of the equation, but you also have to look at what infrastructure changes, especially if we're going to be removing the natural gas generation that we currently have on the grid. In Alberta, we're already seeing brownouts ongoing, right? So, and it's not only in the cold snaps. So, like, I think even last month there was an outage where tens of thousands of homes lost power. In Texas, this happens all the time. So it's about how do we ensure Ontario doesn't reach that point, right? So and the rest of Canada can also be in a more healthy state where they're trying to phase out coal, but also maintain the resiliency of their grids.
Yeah, the reality is in Ontario and in many places across Canada, we need both energy and capacity, right? It's not either or, right? Energy storage will certainly have a role, but you can see, in Ontario, they're going really hard on procuring new energy supply. Also, I can foresee a major role for energy efficiency going forward. Quebec, even Quebec, right? With all the energy that they have, they've announced new procurements for energy, including solar supply. So, yeah, I somewhat disagree with the premise of the comment that came in that we just need more storage. Frankly, we need energy. And we need the flexibility that storage provides to make sure that we can move around that energy in times when we need it. But to Adam's point, there's other flexibility within the system that we can think about beyond just energy storage as well.
I guess the other issue is the whole kind of management of the grid. And I understand, like in Ontario, we have a demand programs, but Alberta, for example, it's got an operating reserve. So how do these different programs come together, or do they work in the same way? Any idea? Is it a hindrance that how the grid is organized?
So 2 wholesale markets in Canada, right? So we got wholesale markets in Alberta and wholesale markets in Ontario. In Ontario, there is a market for some ancillary services, but it's very narrow. We have an operating reserve. You must be a market participant, so that sets a pretty high bar, even though the ISO is talking about lowering the threshold for market participation, enabling aggregations and things like that. Alberta is really an energy-only market, but we can see that they're undergoing reforms there as well with their REM initiative and introducing new structures there. So TBD on Alberta in terms of what they're doing. But in Ontario, it's been talked about for a little while in the wholesale market, trying to enable greater participation in the wholesale markets and in some of these ancillary services markets as well.
Jerry, just to add to that, I believe operating reserves are also available in Ontario, but it's we typically rely more so on the demand response program. But in Alberta, I mean, it's one of the more difficult things about operating reserves. You almost always want to have a third party be in charge of toggling your generators or whatever storage you're using, because the turnaround time is so short. Like typically you only get a 10-minute notice and then you have to be off the grid or in that sense. Whereas demand response, you're usually given like a 4-hour window at least ahead of time. So you have time to manage and get the operations in place. But operating reserves in Alberta, you're going to be enrolled on a daily basis perhaps, right? Just to help continuously keep that load down. However, it is available and it's more lucrative in Ontario as an alternative to demand response. But like I said, that turnaround time, not all operational staff can handle. So a lot of times you may want to delegate it to a third party.
Great, great. We actually had a question which is kind of a specific to buildings, which is like a if you have this the demand, if you're changing the demand in response to the grid, whether you would actually compromise well-being of the occupants in with regards to indoor air quality. For example, if you have a pandemic or other sort of emergency like that. So can you maximize the ventilation at the same time as reducing the energy? I guess that would be it's kind of a health question, like can you maintain the health performance of the building if you changing the changing the load.
Yeah,
I
I'm
may
gonna
speak a little bit. Oh, go ahead, Greg.
go ahead, Hedy. No, go ahead, Hedy. Go ahead. This is your
Okay.
space.
Thank you. So I may speak to some of the government commercial buildings during the COVID-19 pandemic. So we had expected to see buildings reducing their energy use during the pandemic because they were unoccupied. But in reality, we have seen that energy consumption did not change that much in proportion to the occupancy levels. So where we're going to right now is trying to apply demand control ventilation or occupant-centric controls to identify occupancy levels and adjust energy usage or HVAC operations based on occupancy levels. Because the way buildings are operating right now is still not smart enough to identify how many people are in the building. So there has to be some mechanism right now to optimize the HVAC operation based on occupancy.
Right. Actually, we had a follow-up question to the reduction in demand, and that's the case of Australia, which is actually replacing most of the natural gas with sorry, this just jumped. With battery storage costs have dropped 50% in just 2 years. And they also use local grid distribution. Would, for example, microgrids or isolation of certain grids help in this case, or would it be a hindrance? Like if you start introducing microgrids.
Yeah, I think sorry, I'm gonna try to tackle the natural gas and battery storage. Natural gas is an energy source. It provides joules, let's say kilowatt hours for a minute. Battery storage is not an energy source. Battery storage helps with demand and it helps with storage, obviously. But battery storage itself doesn't generate new energy that goes into a building. So I agree. Australia is actually a really cool case study. But to say that batteries will replace natural gas, I don't think was the purpose for why battery storage was implemented in that instance. And I want to go back to the question about and I feel like I'm getting argumentative and that's not intentional, but just back to the 1.5. Like it really matters what problem we're trying to solve, whether it's 1 times or 1.5 or 3 times, right? Like if we're trying to do fully fossil fuel free and get off of natural gas, for example, we're talking pushing the 3 times limit. But if natural gas remains as a heating source, then maybe it's not 3 times. But I would suggest in Canada, natural gas is going to be around for a while yet. We still heat our homes primarily with natural gas across Canada. But all electric homes and buildings exist in many jurisdictions in Canada, and it does work. So there is a potential to actually take natural gas off of the formula. And that's where some of the higher capacities start to show up, and the 2 to 3 times number comes from.
Right.
Sorry for the little rant there.
No, that's great. That's great. Thank you. Thank you. Do we have another question? Oh, that's an explanation from you, Sarah. Sorry.
No problem.
Great. Yeah, I guess this notion of swapping energy from one user to another is really quite intriguing, and I guess what this other question talks about is whether you could not only include not only include electricity but also waste heat and gray water, which some of the people are now doing, like extracting the heat out of the gray water. So like rather than limiting the exchange of the energy, or limiting it to electricity, if you could actually start swapping heat between different places. But that might be a kind of a question for another webinar, actually. Maybe we should put that one together. So I don't know if we have any more questions. If not, I would certainly like to thank you to all the panelists and participants, and we certainly would look forward to seeing you at other future webinars. And actually, I think we've got some ideas here for some future webinars, so that's great. So thank you, everybody, and looking forward to see you in our next show.
Thanks, Jerry. Thanks everyone for attending.
Thank you.
Everybody.
Thank you.
Thanks, everyone.
Take care.
Thank you.